and it looks like this. I call it A, B, C, D, E. A, B, C, D, E, and maybe this E. This E is now discussed in Sweden very lot. A, which you have to start with, is important area. I'm working with, yes, you have to keep the voltage in the system, that is important. Oh, electric vehicles, that is coming now, and wind power will solve the CO2 emissions or whatever. So first you have to say that something is important. The question is what do you mean is important? Is it the method you have, or is it that electric vehicles is because you have, that is important for what you come later then, that if you are, is your contribution in the method, or is it in the area for the impact on the society, or in what way? So in the important area is important. Yes, of course. Next step is many have done a lot. And then comes the important issue, but not all. And this very often I see papers where people say that electric vehicles is important. Because of that I have started to simulate it in the following model. And then from my point of view, yes, maybe interesting, but is this new? Haven't anyone else done this before? Because if you claim that you have a contribution in the research area, you must show that what you are doing is important and it's new compared to in some way to what other ones have done. So this is extremely important. You cannot only say that many have done a lot, this is what I do. You must in some way claim, if you want to have a journal paper, at least the way I see it, although I don't see it in all journal papers. The way I see it is that it's extremely important that you claim that what you have done, other ones have not done. Because it's very often I see papers, you can take transient stability, wind power integration, or whatever that. You see, people have done this, these people have done this, now I do this. Okay? Because let's say load flow. Yes, I mean thousands of people have made a load flow, and then I start to make a load flow. Let's say I have a fantastic new method, not Newton-Raphson, I have the Newton-Soder method for whatever. Then in some way I have to claim that why do we need a new method? There must be some kind of lack in the existing method, that the existing persons, what have done before, it's something important that they have missed. For example, they have not considered this, they have not considered that. My method is more efficient, their method is slow, or whatever it is. So this I always expect, however, and this is always a sentence starting with, however. So when a PhD student come to me and say that I have a suggestion of a paper, I always start to try to find the word however. You can make search in the paper on the word however, because it must be that many people have done a lot, citation, 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 but then however. So I always search for the word however. But then of course you have very good ideas, so this is what I do. Then we have this thing, is the so-called impact. We had a presentation from a person that was a reviewer of Nature, which is this really highly, or science, or this kind of papers. And they said that if you want to have a paper in these very highly ranked journals, you have to show impact. This means, for example, let's say you work with offshore wind power. Yes, important, we need more wind power. Yes, this has been studied a lot of time. But of course they have not yet studied that you must have a fantastic converter outside there, because otherwise it will not work. And then, okay, I designed this fantastic converter, and then the impact is, assume that we can, everyone in the world is starting with this fantastic converter. Then we will reduce the losses in all the future impact, and that will be the amount of energy that is currently consumed in Germany. I mean, you must show that if everyone is doing, or you can take charging infrastructures or something for electric vehicle. If everyone is doing what I'm working with, it will really reduce the losses in the Indian grid with 1%. I mean, in some way, I can say that I don't expect everyone PhD student to write something like this. That's why I put it in parentheses here. But on the other hand, this is very much the question we get in Sweden nowadays from the funding of research. They want to know, okay, you make research, but what's the impact? Why would we fund you with all this research? You must show in some way that this works, that it has some impact on the society or in some way. So this starts to be, at least in Sweden, they are expecting, at least not expect exactly from the PhD students, but I mean, of course, if you are working with something and you can show that with the, if you save energy or you make it more profitable for companies, so in some way that what I'm doing is important for the society in some way, and that is the impact. Of course, you can also say that I have found 10 new problems, so now we have 10 new ideas for new PhD students. That is, of course, also an impact, but I mean, that is more internally in the university. So I think that this starts, if you really want to have an important paper for the future, if you have some kind of, I mean, I also think that it's important for when you are working with something to have some idea. I mean, if you want to explain for your grandmother why you are doing this, I think it's this that is important. Okay, but why should you do this? Yeah, it's interesting with this new control science, H infinity or whatever I'm working with. Yeah, but so what? I remember that I had a PhD colleague many years ago, and he had been to USA and United States, and there he made his master thesis. It was something about the energy function of stability in the system and so on. And then it was very interesting that then he said that when he was finishing, then he had to present this, and he presented it in front of a lot of professors. And one of these professors was a professor in sociology. And he asked, so what? And this is a bit, so what? So he had to explain to this person in normal words, but why? What's the meaning of this stability? And then he has to explain, and then to really understand that, yes, you know that if you don't have a good view of this, then the problem is that then you can get a blackout, and then you don't get any electricity at home. Ah, okay, then I understand. Another issue is that, of course, if you can improve the control science, that is, we have got this question, I have also got this question about, there was a guy that had coordinated control of HVDC lines. And then the question is, what's the value of that? And then they say that, yes, because then you can use the existing power system much more efficient. You can come closer to the physical limits because you have nice control in your system. And then you don't have to build new lines. You can use the existing lines. And that is much cheaper from the society. Ah, then he said. So this is, in some way, economics for the society or for people. So this is, I mean, to answer, so what, to your friends. This is motivating. You have to understand in some way. This is, of course, not trivial to do all these things. The problem for me is that I'm not perfect myself to follow this. I just sent I wrote a paper in what was it, demand-side management potential in the Nordic area. And then I got the reviews, and then I thought about, I had not followed this myself. So it's a good idea, but then you have to follow it up. Okay. Okay. So I will repeat a little about what I said yesterday, and then I will continue from that. First, about this with design on the future. I had a model where I talked in the tutorial about this issue yesterday, and this is a little what you can call it the main aim of what I will talk about today. Because this with high level of, because that is the general area of what I'm talking about, and that is this high share of solar and wind power. And then you come in, of course, how should you design your system in order to get that? And this is, let's say, the general issue in this with high share of solar and wind power. You come to in so what, not so what, but in how should you get it? And the big problem is, of course, today that, I mean, just to be honest, it's extremely cheap with coal. And then the question is how to get that. And it's also the other issue, and that is that if you want to get something new, you have to make money on it. The companies that are building all these kind of new things, that are investing in lines, I mean, in some way they have to get paid. The people working in the companies that are making the wind power plant and the solar power plant, they have to make money, of course. Otherwise, nothing will happen. This is honestly in Sweden today. We have low power prices. We have 10% of the energy from wind power, but today the wind power companies are bleeding, because we have so low prices, and they are selling their wind power to the market at market prices. And then they get an extra uplift with the so-called certificate, but these prices are also low by a lot of different reasons. And that is the problem, that you start with the system and then you want people to go in there, but of course companies will not go into an area and build wind or solar power if they think that, no, it's impossible, I will not earn money. So economics, nothing will happen if you don't have the economic background, whatever the fantastic technical system you have here. So I will go into more detail. I didn't have time for that yesterday. But so, as I said, you have these competitive prices. Everyone say these kind of things always. I mean, whoever the politician you will ask or a designer in the system, they say that, yeah, we're going to have good prices, it should be sustainable and it should be reliable. And efficient, of course. You can have but efficient is also. The question is what you mean here in reality. So competitive prices, this is a repeat, I think I talked about this, but they should be competitive for consumers, and especially in a country like India, where you have rather many poor people, it's a problem to have too high prices, because then people will not consume at all, and it's power is very often in countries where you have poor people is seen as a measure to as a mean to get to increase the society, the efficiency of the society. If the power prices are low, they can maybe start a small factory or something like this. So you don't want to have it too high, because then you cannot see the development. So this is of course a challenge, but at the same time you have a lot of people that without any problem can pay a high price. So the question is, why should you have an extremely low price for people that are rather rich and can without any problem pay a high price? So the question is if you should move the money around in another way, but that's more politics. So, but anyhow, whatever the country you are in, people of course don't want to pay too much. I don't want to pay too much either in Sweden. But then for the producers of wind and solar or whatever it is, the income, they must have a decent income. Otherwise, it's impossible that producers are paid with this and the consumers are paid with this. Then the state have to pay like this. And of course, you can say that the producer want higher price and the consumers lower. Then the state have to subsidize even more. And then the question is, do you really want to have the whole power sector subsidized through the... I mean, you can use the state money. You have a huge amount of other needs. You have schools, universities, hospitals, whatever you want to have in the society. Why should you in reality have so much money that is going through the state to the power sector? Of course you can have it. But there are of course alternative ways of using the money from the state. And then you can have competitive, I think, and that is just what you see in most countries, when you are having a developing mood towards more higher standards, as you have in India, and we have had in Europe also, then of course I think there is at least the solution very much in many places is to go more towards competition in some way. And that is what you see in India. You have this exchange. But then the question, I think that in 10 years you will go more and more in this direction, that you have competition in different ways. And then you have that state may be involved. I think that, the state always have problems in getting enough. Why should the state get them all the money? then, of course, if they have high taxes, who is going to pay the taxes? People normally don't want to pay taxes. And then, of course, if you want to subsidize a sector, that's the problem. So that is one reason, for example, that you can have CO2 tax in order to take away. Then the state will get an income. So you can have two ways. In Europe, we have a lot of these subsidies to renewable energy, which is, of course, is a cost in some way. On the other hand, if you have CO2 tax, you have taxes on the bad things. So then, of course, the state will instead get an income. So this is a challenge on a more higher level. Then we have sustainable power system. And then sustainable is, of course, in a very different way. Sustainable is, I will come to the definition of sustainability. This is very often discussed. And you have this environmental issue, which is low CO2 emissions, which is a global issue. And then you have the low NOx and SOx. High share of renewable. I can say that in Germany, they have very much wind power, very much solar power, but from CO2 point of view, if they changed all their coal to natural gas, it will have a bigger impact on the CO2 emissions. It's the same thing in India. If you build a huge amount of solar and wind power, that will of course have an impact if it replaces coal. But on the other hand, if you change the coal, all the coal to natural gas, you will, because natural gas have only 50% of the CO2 emissions, and if you have a new gas plant compared to an old coal plant, it can be even better, because the efficiency in a new gas plant can be 50%, and then in the gas itself it's only 50% nearly CO2 emissions compared to a coal plant. So if this is the only requirement, then you can have go from coal to gas. You can have nuclear and so on, and then you can have this is sometimes classified as sustainable, which is it's not exactly the same as this thing, and so you can have different aims here. That was this kind of thing you can of course simulate in the program I have. And then you can have this with low NOx and SOx, because the bad air, you remember, bad air, as I mean smog and all this kind of thing, has nothing to do with this. I mean, you can have absolutely clean coal. We have it in the middle of Stockholm, we have coal burning. We don't have any smog or anything like this, because we have good cleaning on it. This is rather modern technology developed. Okay, it's 15 years old, but still it's... So you can have a huge amount of cleaning. You can have burn coal, and you can have NOx cleaning, you can have SOx cleaning, and this kind of thing. So a huge amount of thing you can do. So CO2 and bad air, and sometimes I see too often that they say that we have CO2 emission problems here, and then they show a city or something where you have very dirty air. And that is, sorry, that is not the case. I mean, it can be extremely clear, fantastic coal burning, and it's extremely bad. So it's absolutely no problem. You have fantastic clean air, but you still have this problem. So I think you have to, when you are discussing sustainability, it's very different what you mean here. And then this was sustainable from economic point of view. For me, it's very hard to assume that we will have zero prices in the future, because we have so huge amount of wind and solar, so the price will need, because the marginal cost is zero. If you only have power plants with marginal cost zero, if you then have a power price which is zero, who is paying for the plants? That doesn't work. So it must be in some way, and that has very much to do with this economic balance. It has to do with the sustainability from economic point of view. The companies must be healthy that is working with this solar and wind power plant. You cannot have it as in Sweden today. Today we have so low prices, so it has been company that owns plants, and these companies have borrowed money from the bank to buy their wind power plant, and then they are paying back every year, both for the interest, which is not so high, but also to pay back the money they have borrowed, and they don't get enough income. So what does the bank say? The bank could say that you are not following our rules, you are bankrupt. But that is not happening in reality, because then the bank will own the wind power plant, and they cannot earn more money either. So what they are saying is that, okay, just pay, and you can pay back the money later. So, and that is of course not economic sustainability, because the prices are not high enough for the power plant owners. And this, of course, whatever the system you have to have, it must be sustainable. Can you really have a sustainable system where the state is pushing a huge amount of money continuously every year into the power sector? Where does the state get the money from? And then you get this Bitcoin and everything in the economy, which is really reducing the amount of money. It is sometimes destroying the possibilities for the state to get more money. And then this is a social point of view, of course, that people have to accept what you are doing. They cannot just start to work against it. This is a problem in Germany with social acceptance in one way, and that is that transmission lines. Transmission lines is very controversial in Germany, not so much in Sweden. More in United States is also very controversial to have lines. So you can, I don't know in India, but normally this can be controversial. But in Germany it's very controversial to have new transmission line, and that is a problem because you have the wind power in the north and then you have the demand in the south, so you really need new transmission lines. So this is the definition from 1987, and this I think is extremely important, of course. I think it's very hard to say that I'm not working for this. Development that meets the needs for the present generation without compromising the needs of future generation. As I talked to someone today, I can see a kid, let's say 4 years old, and this kid will live year 2100. And of course, we want to have a good living standard today. I think this should also have a good living standard in 2100. So I think it's very strange if we try to solve our problems now without thinking about the persons in 2100. I think it's extremely important. So from my point of view, this is really the basics, which is of course, but it's important to remember that that includes all these kind of things. Because sustainability cannot be that we borrow money and we are borrow money, and then they have to pay back in the future sometimes. That's not fair. And then of course you can borrow money from the state. The state is borrowing money, have a deficit in the budget all the time, borrowing, and then it's the next generation that have to pay back. And then I have a good standard, but that's not fair. Then we have the reliable. Everyone say that we want to have a reliable system in the future. This, I think, is very much the so-called adequacy challenge, but it's also a security challenge. The adequacy challenge is, of course, that we must have enough resources. Adequacy is very much that if the demand in India or in the state of India is like this, we have to have resources like this. Okay, you can get outages, so you have some kind of, that is the fundamental adequacy issue. You must have enough power plants. And this is an issue which I showed you in some problems earlier, that if you have a lot amount of solar and wind power, you can get problem. It was very interesting that with this example I showed you with a huge amount of solar power, the problem seemed to be in a high load situation in the morning when the sunrise has not come up, but you still have a high load, but you didn't have all this contribution from the solar power. That seemed to be the challenge. If it looks like that, of course, I don't know, because I took the Swedish load, not the Indian demand. And this means in reality that the loss of load should be very low. What I have written here, which is of course relevant for India, is the distribution system, that you must have a good distribution system also. It's not, adequacy is only on the top level. It's on the that you should have enough capacity in the system or in the region or whatever, including import. So then you have, of course, that it's not enough just to have capacity. You must have capacity of transmission from the wind power or from your sources out to the consumers, which is an extra, called it transmission, transfer capacity, which must be enough. And then there must be, of course, enough margins for operation. It's not enough. You must have, since the wind and solar is uncertain, you have to have extra margins, primary, secondary, and all these kind of things. And then, of course, you must have this security. And security will be, of course, a challenge when you have a low inertia system, which is one of the, that should be a low risk for blackout. But we have had also blackouts in Sweden. You have it everywhere. I don't see, it seems to be impossible. I mean, I know that there is a big meeting in every year in I think it's, no, every second year in Europe called SIGRE, which is they also have meeting all over the world. But there, I think the most popular sessions is that people try to explain to each other, why did we get an outage? Because you have all these outages, you have it every year. You have had it in Italy, you have had it in Germany, you have had it in United States. So this is, I mean, it's just to say that this, you try to learn something what have really happened in other countries. The challenge is always that when it happens, it is also a thing that it's of course always something that you haven't thought about, because if you think about it, if you consider it in your calculations, of course you have measures, so this will not happen. So it's always depending on that something worked, something did not happen. What I think is an important issue in the future, which I think is a challenge in the research in itself, we are discussing it in general. Let's say we have a transmission line from point A here to point B. And then the question is that, yeah, we have a line here. The question is, how much should we allow to flow on the system? Perhaps we say today that we can allow 1,000 megawatt, just to take an example. Why exactly 1,000 megawatt? Why not 1,001? Because when I see these transmission limits, people say that. And then I say that, but how did you find out exactly 1,000 megawatt? Why not 1,000? Do you mean that 1,001 is impossible? And 999 is completely okay, no problem forever. 1,001, absolutely not. Of course, that is not what they mean. So they say 1,000 megawatt, but they probably say, yeah, you know, that has to do with n-1 or something, that we have a parallel line, and if you get an outage, this is okay. Or if we get an outage on this one, then 1,000 megawatt can flow in the other one. Aha, so you mean that if you have 1,001, you get a blackout? No, we don't get that. And what I think is that what will happen probably in the future, and that is what we are working towards, is that I think that if you have good control science, and if you have good PMU measurements and so on, you can sometimes say that, yes, right now in the current situation we can have 1,101, and next hour we can have 998 and so on. And I think that you can come closer to the physical limits, because why you say this? It's you have another issue with this, with blackouts. The problem is that blackouts is extremely bad, of course. This means that probably you are firing the CEO of the company or something. I mean, something big happens if you get it. And they hate to do that. So they are keeping a huge amount of margins. If, for example, it may happen that you can transfer 1,000, but they say that, no, I'm so afraid of a blackout, so I only say 800. And of course, if you reduce the use of the transmission system, you're not using your resource. You are putting a huge amount of money in building all these kind of things, and you are not using it. Why shouldn't you? And so I think that here, to really use the current assets, and here we really talk about impact. What is the use of using control science here in order, and PMUs and so on? Yes, you can use the existing assets much more. And then, of course, if you make a calculation of the Indian system and say that, yes, with this new fantastic resource of this controlled science, we are using PMUs, we can transfer more power and so on, then perhaps we can use the existing resource, let's say 10% more, 5% more, 1% more. It's a huge amount of money if you can do that. On the other hand, then perhaps there's a risk. You have a risk here, because if you do that, there's a risk that perhaps your security margins are decreasing. So, I mean, this with economy and security, it's extremely important to try to balance that in a good way. And I can generally say that if you have knowledge, much more knowledge about exactly how the system is working, I think you can run more power. Because there is always a discussion that if you have these PMUs, I often say like this, that if you have PMUs and fantastic control science, you can increase the use of the existing system. But some people say that, no, you can instead get more margins in your system. You can get a more secure system. The question is how to balance the security against the economy. Because, of course, if you don't use your transmission system, you have to build more transmission system, perhaps. Okay, so this was just in reality the start of the lecture I had yesterday about how to design the system, but we had a tutorial only, so I only had a practical example. This is because I will have in a while I will go through that there are a huge amount of studies in the world. I mean, every country or often university are studying how should we design the future in some way. But then there are, of course, I showed it a little yesterday, the question is how you set up your system. Because when you see this kind of integration study, let's say if someone had made a study, what happens in India if we have 20% of the power from solar, for example, or that is not so high share. We say 30% of the Indian energy from solar power. Then, of course, you can have a greenfield study, which means that you say, yes, 30% solar power will not happen until 2050. So, and then all power plants are rebuilt. So the question is, how should we design the future power system in India? Or on the other hand, you can be perhaps a bit more optimistic. This will happen 2025. But then, of course, you already have a huge amount of power plants. So then you are talking about this. So you get very different results if you look on this one or if you look on this one. Then you have these requirements. You can, of course, have a requirement, as I showed you yesterday a little, that you can say that in the future system, whatever it final system, you can say that it should be 100% reliable. I should never have any problems, which is, of course, impossible because you can always get blackouts. You can run your... The question is, what is the transmission capability and so on. Just in general, I see they are writing. That's not absolutely not a problem, but I have a compendium of this which I sent to none because this we have in a course. Sorry. So the requirements is then, of course, you have the reliability. You can have... The question is what you are doing because you will get different results. Is your have minimum... The cheapest solution may be to change your coal to gas. I don't know how... Then I mean, India is a big country, so then you need a huge amount of gas. Or you can say that, no, the important thing is for India is to get a huge amount of renewables. And just remember, these are different things. It's very often that say that we are reducing the CO2. Because of that, we have to have wind and solar, which is not correct. You can change. If the only target is to get reduce the CO2. On the other hand, you can only reduce it to a certain level then, because then you still have the CO2 from the gas. And then you can have the different issues here, minimum cost or market driven. Minimum cost means that is what you are normally doing. I want as a cheap future power system as possible in the future. The problem earlier is may include that the prices are so low, so the power plants will not be profitable. You have something called, which is very much discussed currently in Europe, and that is the so-called cannibalizing effect. What is happening is that when it's extremely windy, the prices go down. And that means that if you come with a new wind power plant, the effect becomes even worse. So what is happening is sometimes that the owners of the current wind power plants don't want more wind power, because then you are reducing the price even more. So for each new wind power plant, the existing one will earn even less. And you have the same with solar power, of course, that if you have a huge amount, let's say 20% of solar power plants, if you buy 1 megawatt extra, what are the prices that this extra megawatt will earn? I can directly say not much, because when it's a huge amount of sun, the price will be extremely low. And that is the problem of minimum cost. You don't see these kind of things. You just try to find out, oh, okay, the investment cost in solar power is cheap and that is better than coal or whatever it is. So and that may be a good idea, and you have put a requirement on the renewables. The problem is that that doesn't mean that the society is going to build it automatically, even if you have subsidies, because the prices will be so low. So you then have to check what is happening with the prices in this system. Will it be profitable for the company to do what you say? So, and I showed you yesterday that you can have this kind of setups where it is extremely, this is the absolutely cheapest possibility to have this. But sorry, it will not be profitable for the owners of the company. And then the question is, will this happen? No. And then the question is, which prices are needed? I mean, how do you have to set up the markets? So what is the good for the society, which is the minimum cost, will also happen in reality. And that is, let's say, one of the fundamental issues with the so-called market, where you have everything is driven by prices, as everything else. I mean, cars, whatever. I mean, of course, you have a car, you buy the car, and then you pay per car for the price. And the factory that is making the cars, of course, that factory, they are taking the cost for the car with the car costs. And then the question is that why don't we have the same structure in power? Okay, I have a power plant, I'm selling the power, and then I get the money so I can finance my plant. And that is the, let's say, these are rather different. And I think that also in India, I think just, of course I don't know, that you will go towards this, because the benefit of this is that you get competition, and that means that the bad plants, for example, bad coal power plants with low efficiency and so on, they will be out of the market because they have to be better. Otherwise, sorry, you cannot be here. The state control is that you keep a huge amount of really bad plants that are really never used, and they are bad from all points of view, efficiency, maintenance, everything, and they are still there because, of course, we get money from the state, we just continue, we have employed people here, so we keep it, and then, sorry, it's the consumers or the taxpayers that is paying the money. Can't they use it to something else, for example, hospitals or solar power or whatever? And then the question is, of course, what do you have as input in this kind of studies? I mean, one idea is, of course, to have CO2 prices, which is a good idea, but that is not the same thing that we will automatically get it. It's very often in Europe, you say that in the future we will have more renewables, and then I make a study, and then I see that, oh, it's fantastic to have renewables, and it will be profitable. Okay, and then the question is, okay, which CO2 price did you assume? Okay, this level. But sorry, this will not happen. We don't have the regulation that will have this CO2 price. Currently, the CO2 price is like this. And then, of course, everything disappears in their conclusions because they have the wrong assumptions in the beginning. And then, of course, this with taxes and subsidies. So this is just all this kind of thing. That is the idea. So the tutorial I had yesterday, that's a huge amount of thing you can really study. The question is also, the interesting thing is the combination here. You can have market-driven, high reliability and a greenfield study, or you can have minimum cost with CO2 and additional investments, and then you have this or this or this and so. So there's a huge, I mean, the issue, let's say, when you're, let's say, talking about the future is that, I mean, it's a huge amount of things that can come in. So when I see a study and I comment on that later because I will show studies. I know that, okay, you have made a study, okay, what are your assumptions? I see your results, but how did you come to these ones? Which model did you have? So it's I mean, you are engineers, so of course you understand. You have input, model, output. And if people only talk about this thing, without talking about this, without talking about this, it's extremely difficult to say anything about that. On the other hand, that is a very engineering approach. Very many people say, but this guy said this. This report said that it is like this, that solar power is stupid or solar power is fantastic in India or whatever. But then the question is, okay, that depends on this one, depends on this one, and so on. The problem with what I say is that we are often discussing that. If you someone asks me, let's say, is solar power a good idea for India? Then the really scientific answer is that, yeah, it depends on how you see it. You can never say yes, you can never say no, because it depends on all this kind of thing. Oh, yeah, maybe. And that's rather boring, so you can never interview a professor. They cannot say anything. Okay, this was very just very basic. Greenfield studies, it says assume that in the yes, this is just about the greenfield study or additional investments. Yeah, this is in reality I already talked about minimum cost, and then the question is, for example, should you have this is the cheapest solution. That was an issue that I I realized after a while. I used minimum cost for a power system, but at the same time I have assumed a cost of CO2. So of course I have the minimum cost solution, but then I assume that all you have to pay extra for your CO2 emissions. So then of course I have the cheapest solution. Okay, but some come from the CO2, and then the question is, what did you mean as cost here? That is of course a challenge. I think I mostly talked about this thing, reliability, share of renewables, I think, yes. So this is, I think, and the challenge when you make a study is of course that, just is how you design this. Just one thing that I have not talked about here at all, because that's not in my model. The question is, when you talk about optimal transmission system also in the future, or optimal distribution system, grid upon this also. Because here, this is a pure production system. I assume that the transmission and distribution is working. So that is not the problem here. In reality, the transmission and how you design the transmission system, should you have 2 lines like this or 5 like this, or how should you design your system? That is, of course, an issue in itself. That is, I know at least in Spain they have made one PhD in optimal transmission expansion, and there's a new one now coming into optimal transmission expansion. So this is a big issue in itself. Okay, this is what I talked about last time. So now I go to the next one. I have lectures for around 3 hours more, which I should compress to 1 hour, so I think I have to skip some parts. 10:45. Okay, now it's 10:15. Okay. I'm participating in a group, which is you have the IEA, International Energy Agency, which is an international organization. They have their main office in. Okay, was it his phone or? Okay, whatever. No problem. Okay, it works. This IEA, they have so-called tasks. So if you want to know something about what is very much of what I'm saying here, about different countries in the world and what's going on, this is information I have got through this network. This is a network, so we are meeting 2 times a year. I've been involved in 10 years in this, and it's called IEA Wind Task 25, which is integration of large amount of wind power. We are now also including more and more solar power. Because in reality, in the countries where you have a large amount of wind, for example, Germany, you also have a large amount of solar power. So if you want to know a lot of the things that I've talked about, you have presentations and general facts on this IEA Wind Task 25 homepage with a huge amount of references. And we have written a report concerning recommendations for wind and solar integration studies. And just so we understand that when I'm talking about this, you can call this large-scale integration. It's not distribution system. It's not, let's say, exactly transient stability and this kind of thing. It's more these large-scale things that if we have a demand like this, and we have solar like this and wind like this, we have to something extra. And if everything is varying, we must have ramp rates which are good enough in the other power plants to follow this wind and solar, very often on an hourly base. And that is very much of these studies. But anyhow, of course, the other issues are important. So because of this, within this network, I just got the information yesterday that we are going to continue. Formally, we get the funding in the 3-year periods. And I'm the Swedish representative here somewhere. And from the other countries, it's very often that you have for example, from France, it's the system operator that is participating here. From Denmark, it's also the system operator. And now we have Mexico are involved now. And I hope to get, let's say, South Korea. I don't know if India is, because this is, I don't know, since wind power is not a very big issue in India, perhaps, I don't know if India could participate here, but it may be possible. Then you can just send an information to, it's Hanneli Holtinen, she's from Finland, and she is the operating agent, so she's running this cooperation in reality. So we have 2 meetings a year, and we do write reports together. And it's very much reality here. We are talking about models, but it's very much that but it's also very much these kind of studies for the future. Can you close the door, please? Close it. Totally. It's sound, so it's sound. Yes. Thank you. So I will just say a little about this, that we have then made a recommendation. I will not go through all the details here, just to say a little about what we are doing. The issue is that, let's say you want to make a study, for example, how much wind and solar can I get from let's say you want to study 30% wind power in India. What should I study? And how should I do it? And this is, of course, then we nearly come into my idea here that this is the way you do it, but then the question, you do it in another way. But this is, we just say a little about in what you should consider. And that is because it's, of course, important when you see a study, have they really studied everything, or what have they left out in some, you can call it. So because of that, we also have, just to make some kind of advert for what are you doing. For the ones that are interested in this kind of things, we have a yearly report with, let's say, 150 pages with a huge amount of references. And as I said, very much of this, what I showed here, is coming from this kind of reports and the references. So here it's called Design and Operation of Power System with Large Amount of Wind Power. But what is happening now, which has come in the last 4 or 5 years, is very much the solar power is increasing. And that, of course, has a very big impact also if you have wind power in your system. So this is, and then we have made this specific report on recommended practices to provide research institutes, consultants, and system operators with the best available information on how to perform a wind integration study. And then, as I said, this is you can call it the large scale. Also, here information about methodology only. Summary report contains summary of recent study results. So here, what I will talk about now is just what should you consider in a study, which can be important. And sometimes it's important, and that is different. So this is, okay. This is the very complicated scenario. I will talk a little about it. Wrong place. Thank you. So, wind technology and resource and location. This seems very simple. The question is, what is of course very good is to have, let's say we take India for example. you have a lot of states, and you have demand that is changing, and then you have a certain amount. Let's say you can just take them, have some measurements, and you just scale them up. But on the other hand, it can be different, very different years. And then the question is it enough to have 1 year, or how many years should you have? And then, of course, the recommendation is, for example, in Sweden, as I said earlier, in Sweden, the problem is that the peak load when it's really cold. The question is, how windy is it in these situations? Some years are very windy, some years not so windy. And if we take India as an example, for example, when do you have the peak demand? The problem, I think, in India is very much that if we look in the future, if we assume an increasing, assume an increasing economy in India, people will have better economy. Just what I think when I hear that it's 45 degrees in the summer is that then you will probably have more air condition. The air condition will probably come somewhere in the future. So here you see, it seems extremely simple. Yes, we get a solar power as a forecast, but here the challenge is very much, okay, but we are talking about 30% wind power. It's probably not 2018, it's probably later, 2017 or 2025, 2030, something like this. And then, of course, the question is, but how will the load look in these situations when people become richer? So just to make a good estimation of the demand is, of course, important. And then the question is, of course, you have the office hours, and then you in some way have to estimate how the demand will be in that kind of specific situation. And then, but then the very fast indication that I had earlier was that the problem of the capacity is not in the middle of the day. The problem seems to be probably if you come to work in the morning, perhaps you put on the air condition before you get the power from the solar power. So probably the possible dimensioning problems in India may be, let's say, early morning. Let's say what is the load, the net load at 7 o'clock in the morning or 5, 6 in the evening. Because as I understand here, you work until 6 in the evening. And then you are working, you want your air condition, but there's no solar power. So probably the problem is, I think, 6 o'clock. It's not the peak in the day, which is the peak today. So it will be, and this really fundamental issue up here, you really have to identify what is the problem in your system. And I think that just to have this kind of thing is just a research issue in itself. In Europe, it's more like this, that if you take most European countries, I think the demand is rather well known, and we will not. What is discussed in Europe nowadays is more the electric vehicle demand. How will that look if we get a huge amount of electric vehicles? When will they charge? Will they charge in the morning or in the middle of the day, and so on? And that can have an impact, which is, let's say, a bigger impact on the demand in the future. But this with air condition, that I think, I'm not sure, but I think that could be an issue. On the other hand, what is also probably happening in India, I assume, is that I assume that people still have bulbs, where I think that on the other hand, in the future, they will have LED lamps, which are consuming extremely less energy, and they will probably go down in price. So I think this, it seems a simple thing, but I think that it becomes probably rather wrong if you take that a load will be the same in 2025. We just scale it up with 10% or something. Probably it will change in some way. So a very small thing here looks like it's of course important, but what you do here is of course important for the conclusion if you really want to say something about reality. And then what is important is, of course, to have them coordinated. So the load and the wind is from the same year. Because probably, I don't know exactly how the temperature is in India and this kind of thing. That, for example, when it's 45 degrees, is it then really sunny? Can it be very hot and cloudy? Is that possible? Because that is of course important. Let's say that it could be like that it could be very hot and cloudy. Then of course you have a problem with the solar power, because then you don't contribute in the same way. And then in Sweden, as I said, it's very, I think there should be a correlation, of course, between the solar power. And then I mean, really, I don't mean that it's sunny. I mean that you really get sun, you get a clear air. Because I don't know that can, at least what I know in Delhi, it can be rather smoggy sometimes. And then what I don't know, I assume that it can be very smoggy and at the same time very hot. And then I don't know exactly how much of the solar power that the smog is taking away, if it's 50% or 70%, because just some clouds really take away a lot of the solar power. So it may happen that that takes away. So, and of course, also, on the other hand, I hope that you will have cleaner air in the future. But on the other hand, you also have these fogs, as I understand, around Delhi, which will, of course, has nothing to do with the dirt. So, I mean, just to get an estimation of this is certainly an extremely interesting issue if you look at for India, just to get a good approximation here. I think it has a big impact on what is, let's say, a good solution for India, which is an optimal power system and so on. So that is, let's say, step one here. And then the question is existing system data. You have the demand, but existing data, I think this is, a problem is here that this is very much, the persons here is very much European and Americans. And I think that India has other challenges since you have an increasing demand. I think changing structure of the demand, because here the existing load, I'm not so sure that it is of course relevant. I mean, as you say, that the main in the southern part of India, where it's probably more sunny, there you don't have as much people, not as much load as you have in the northern part. So I think that in some way you have to understand in which part of the area you have. And then you have the existing grid, for example, the existing power plants and so on. And then the question is portfolio development. What will happen? You can have scenarios for wind and PV, and that could, the question is, for example, the PV. Where will you get the PV? Where can you really, let's say, should it be on each person's house, or should you have big farms? Where do you really have room for the farm? So in some way you must have some kind of scenario, and that will of course be different if it's in the distribution system, big farms in the central systems and so on. So then of course, say it for India here, conventional generate demand response, that could of course happen. I don't know if it's, and storage of course. The question is, you should have portfolio development, for example storage, should you see storage as an output or an input? I mean, you have your model for India here, and then the output is, okay, what are the consequences? And then, of course, you could have batteries here and say that we assume that we have batteries in all houses. So they can store from the peak of the day to the evening, for example. Because it may happen in India, if we look on the things I showed earlier, that you get a high surplus in the middle of the day, but on the other hand, you may get the problem in the evening between 5 and 6 when it's not so sunny, but you still have your air condition. So then, of course, it may be interesting to have batteries. But you can also say that, yes, your tell you if it's good to have batteries or not. Of course, you can also have different scenarios. Would you try which problems do I get with batteries and without batteries? And that is, I mean, to think about what is input and output here. And then you can have network scenarios, of course. And I assume that, of course, if you, let's say, I don't know, as I said about India, where you can have the solar power, but you can probably get some kind of rough estimates that, okay, then we need more grids. Because what will happen then, that what you saw is that, let's say, take Delhi, for example. This means that in the middle of the day, there's a huge amount of consumption. Then the question is that then you have the solar power that is really transporting the power from the solar power to the cities where you have the air condition. And then on the other hand, then you have the sunset, and then you still have and then you will completely different flows in the system. And then the question is, from which power plant will you then use in the evening between 4 and 7 when you don't have the sun but still the high demand? So then, of course, that has an impact on the network. The question is then that if the networks is an output or an input. It could, of course, here we are more seeing it as this. You can call it, this is more a simulation. So then we can, of course, here have a certain amount of grids. The question is, which grid should we have? One idea is to start with a small grid. I think that what you should do, if you do it for India, you should only have different states. As I understand, you have 29 states, as I understand it. And I think that the best way should, of course, not be to have a perfect grid. You just take the 29 states and look on the demand in the states and so on, just to get the first view of how it looks like. But then, of course, you have to do something about how is the transmission capability between the states to get some kind of idea here. And then, of course, you can come to congestions. It may happen that you see that sometimes you are, and then, of course, you come to my idea, what I thought about there. The question is that, okay, let's say you take two states. The question is, what is the transmission capability between these two states? Okay, should you have 1,000 or 1,100 or 900 in this small case here? But so that is a challenge in this set, just to set these kind of ideas. But in some way, you need, of course, a grid model. In United States, which I think is of the grid sizes sound the same as in India. I think it's higher load probably than in India, but the size of United States is probably around as India. There they have made studies, but they have made a so-called Western integration study where they have simulated in reality whole Western United States. I don't think they have, I'm not sure if they have studied the whole nation, because it's a very big, because the question is how much of the grid the details can you have if you study all these kind of things for a huge amount of hours and a lot of scenarios. It's complicated. And then you have this with change system management. That is a little what I talked about earlier. Should each control area keep their own balance exactly, or can you assume that if I have a problem in my area, I can get the help from my neighboring area? Should you assume that each state is doing that? Because that has, of course, a very big impact. And I can say that this is, at least in the United States, when they have studied these things with more wind power, just that the states starts to cooperate more with each other can release a lot of the problems, instead of each state should, then I mean, let's say it can happen like this, which you have had earlier. Hello? Yeah. It may happen that following is happening, that here we have wind power, and we have wind power, and in area A it's increasing, and in area B at the same time. They say we have the same demand. What you then can do is, of course, okay, it's a room, because here is increasing, then we don't have a problem. The problem just today is that you very often have control areas. This means that you have a secondary control, which is checking that here we should have the already defined trade fixed. And the reason is the market have decided that suddenly the wind goes, aha, there. Okay. Aha. Wind power. So then you get, just because of a rule, trading rule, instead of transmission, you get a change production both in that code, which I really doubt is efficient from the system point of view. So, and this is what have happened much more and more in the United States when they got more and more solar and wind power, is that they start much more with their neighbors. And that, as I said, I don't know anything about how this is handled in India, but I assume this is such a large system, and it's also not an extremely expanded transmission system because you don't need it. Then I assume that you are working with control areas, and that means that probably they have this set up. I don't know. And on the other hand, you don't have so much. So I think a problem is that it may be very efficient today to do that like this, to have this fixed trading between the areas. Because especially if this is a very weak line here, then it's good to have this, let's say, fixed trading there. On the other, because you don't have so much wind and solar power in these areas, that is changing. So I think that it may be that this is very efficient to keep this structure today, but that is one of the issues here. Don't assume that what is good today will be good tomorrow in the system with large amount of solar and wind power. Think about what are the rules. It's not only the technical voltage, Ohm's law and Kirchhoff's law and these kind of things. It's a lot of these other assumptions, which is very often, I've seen these papers where they simulate this, and then I just see that, but why do you assume this? I've seen, for example, papers from China where they assume that this power plant must be run before this one. And I also heard earlier from China, it was like this, that the state company have a contract with a plant, contract state you to run. You have the contract stated that you are allowed to send power, or you should deliver power to our system during 7,000 hours a year. Then you come, and from economic point of view, of course, if it's a lot of wind, you should decrease the coal power. No, sorry, we have a contract with that coal power company that they should run all the time, so you curtail the wind. Which, of course, this was some years ago, and I think that this is improved now. But this is the type of contract have, where the then for the coal power companies, then of course that, yes, I have a guaranteed income. I run 7,000 hours a year, I have some kind of maintenance, I keep the reliability of the system, or my power plant, and I get a guaranteed income. Very nice, I run it. And then someone is saying that, no, and then you start to curtail the wind, because the wind was installed later. I must say that it's stupid to curtail the wind if you can curtail the coal power. Yeah, but we have contracts. And then, of course, you have to think about, and it's very often I've seen in some papers, especially for countries like China, for example, where they assume the current market design for a future situation which is completely different. And then, of course, you get very, very strange results. This is not an efficient way of operating your system. But that is the problem that, I mean, you are power engineers, you know, I mean, you know what efficiency is, what is good and so on. It's just engineering based. And I think that is, of course, the very good start to think about how should we operate this. Not only look on which are the rules we have of today, how to fulfill these ones. But then, of course, you get the problem that the coal power plant, if they are not delivering all the time, they will not earn so much money. And then you have this kind of basic challenges here. So change system management is very, very often the first step. You don't have to have new reserve plans. I mean, in this case, because this is discussed then. Okay, if we get more wind power here, we have to change. But sorry, you have to check how much neighboring states is changing. That have to be. And that is very much so this is, as what I've seen very often is that this is step one. Try to identify these problems. So this is, let's say, just to say something about the general issues here. Then the question is, okay, now we have some kind of ideas about how to do it in the future. We start with the load flow, and that is, of course, the absolutely basic thing. The load flow has to work for the different situation. We have a huge amount of solar power. I mean, let's say that this is India. So we have a huge amount of solar power here, and we have a huge amount of consumption here. Is it possible to transmit this power here? And then perhaps you have a linked state here. So load flow is, of course, step number one. The load flow must work. You can never have more power than the load flow is saying that this works. And then you have, of course, more issues. Then if that works, then you can say that, okay, what about the dynamics? That is, I mean, to be honest, that comes later. Because dynamics can never work if the load flow doesn't converge. So, of course, you must have. So first the load flow must work. And here you also have the other issue, and that is the distribution grid, what we have discussed in the beginning of these lectures here. The question is about the distribution grid. If we have a huge, let's say we have 20% of solar power in India, 20% of the yearly production from solar power, Then the question is, where is this in reality? Is it in the distribution system, or is it in big farms that are connected to 11 kV, or are they connected to 66 kV, or to the transmission system? Where are they connected? And if they are connected in the distribution system, of course, you have to have an idea that, yes, it will work in the distribution system. Otherwise, it will not happen in reality. So load flow must work. Let's say just this simplified thing about, let's say we have a simplified model of India, where you have the 29 states, and then you have a simplified grid representation of what you have, possibilities to transfer between the different states and so on. That is, let's say, step one. That's load flow. And then you come into dynamics. This is a very big issue, of course. This is extremely difficult to do in a simplified system, to just have one node per state and represent the dynamics. That is, I can directly say, very complicated. I think you need to do something that is relevant. You really need a good load model there. To really make, let's say, have a grid of India with 29 states, and then interconnections between them, and make a dynamic simulation which is really representative. That's not so easy, I think. I think you need at least much more nodes, for example, because otherwise you have to take all the coal power plants in one area to represent. I have not gone into the details there, but I assume that it's a bit complicated. On the other hand, it's also complicated because you don't get the data from the national grid, so which we don't get in Sweden either. I have worked since 1982. I have never seen the data from the transmission system operator. We never get it. It's a military secret in reality. I don't know. It's very easy to look on the map. Put a bomb there, and then we don't have any power in Stockholm. You don't need a load flow model. I think this is a very strange way of saying that it's military secret. Some people say that like this, that if you get the data, you can check it, and then you will find where the errors are. And then you don't believe in the system operator any longer because the data are completely wrong. So sometimes, I don't know. That's the problem. Anyhow, so you have the load flow, which has to work. And I think this is, let's say, step one to really look on the load flow. But of course, when you are saying 20% solar power in India, I still think you have to have some kind of ideas. Can the distribution grids of today really manage this? It may happen, I don't know, that the large problem in India is if we should have 20% solar power in India, perhaps the big problem is the distribution grid. What I wonder, and that is this, you can call it a forecast or something, and that has to do with that I think that in India you will raise the tariffs because you will not get lower costs in the so you have to raise the tariffs for the consumers. And at the same time, currently the power price, the solar power price is decreasing. So perhaps in a while it will be profitable for this university that instead of paying for the grid, you put up solar panels on the roof. Why not, if it's cheaper? Or will someone say that, no, we forbid you. You are not allowed to put up solar panels on your roof here. And I think that this, of course, and if that happens, then, so you don't control it, then if that will happen automatically, then, of course, then you really have to think about how to design the distribution grid. It may be that this is the issue. I heard earlier, I don't know, that the losses in the distribution grids in India is rather high today. So it may be that this is the largest challenge also for if you have solar power. On the other hand, if you only have little solar power in the distribution grids, then you are improving the system, because then it happens that, for example, in this school here, I don't know how often you have air condition, but I assume that you have air condition in when it's 40 degrees and you are teaching. And then, of course, if you have solar panels at that time, it will reduce the problem in the distribution grids in the beginning. But if you are going to have 20% of India, so that is an issue with solar power, that in the beginning, you are improving the system in the distribution system, I assume here in India, because I think the peaks are really much the air conditioning. And this means that in the beginning, when you start to get more solar power here, you will help the system. But on the other hand, when you get even more solar power, you will start to power, and then you can get the problems in the distribution grid. So this, from the start, I don't think this is a problem. But on the other hand, 20% of yearly energy from solar power in India, then this will, of course, be an issue. That was about grids, and I have half a minute more. And then what should you study more? And that is, let's say, the production cost simulation and flexibility. The production cost, and that is, then we look on these large-scale things which I showed you yesterday, where you have, let's say for whole India or for each state or something, where you have the solar power is going up and down. And then, of course, when it's not sunny and you have a demand, then, of course, you have to cover that with other power plants. And then you have, as I assume, if you have 20% solar energy in India, you will have significant ramps. You will have big ramps in the morning, even if you have this time shift of not only internally here between the clocks, but in reality a time shift of the solar power, sunrise and sunset of some hours over India. Then still, I think the ramps in the morning and the ramps in the evening will be rather sharp. And then, of course, you must have other power plants that are, let's say, matching that. But that very much, I really should be interesting to see. Let's say we take demand here. Let's say that this is the demand, and then we have the solar power. So in the night here is nothing, and then it goes up here in the morning, something like this. The question is, what I must say that honestly, I don't know if, because I think that the air condition you will put in perhaps earlier you come to work. It depends on when do you start to work here, 9 o'clock, 8. So you start to work, put your air condition on before the sun is coming. At least in the evening, I think you work longer. So I think, because here, the question is, because here you have a significant ramp of solar power, but at the same time the load is going up. The question is, which is the fastest one? Is it this one or is it this one? Because if they are the same and they are at the same time, then you decrease the ramps in the power system in reality. On the other, and in the evening here you have the sunset, the solar power is going down, but at the same time the demand is going down. If they are, of course, completely matching, then you get lower ramps with solar power day, because all the daily variation is covered by the solar power. But on the other hand, I'm not so sure that that will happen, and it may happen. The ramps, I don't know. So there are certainly interesting. You cannot say automatically that just because the wind, you have high ramps in solar power, but if they are matching with the demand that is going in the same direction, then of course you are decreasing the ramp. So this with flexibility and assessment of what you need, if it's okay what you have today, then of course it's this is really interesting for India, how it will look like. Okay, very interesting. Now it's a break, 10:47, 2 minutes late with that clock. Here I not even come to 20, but it's that one we are following. Okay, so we have a break until 11. Yes, short break just. Okay, we can take it 11.